Hey guys, we're just getting set up here, so we're going to be muted for just a few minutes, but we'll be with you in 3 minutes, letting you know. All right, so what is the topic of today's session? It's weight. It's not what it looks like. Okay, it's not what it looks like. All right, that is the topic of today's session. Now, what does that mean? Well, read the description. It says a little bit more, but we'll talk about that in just a few minutes as well. So, are you guys here? Can you see me? Can you hear me? Just want to check, make sure I'm coming through loud and clear. And yeah. You see me, you hear me? We've got apparently 2 people watching this right now. Few people? Okay, great. We've got a few people here, it looks like. Welcome, welcome everyone. It's nice to be here with you. Happy to be back, actually. This is my 3rd one of these presentations with GMAT Club. I really enjoyed doing them. I hope you enjoy watching them. If you do, make sure to like and subscribe, because I know that the GMAT Club channel has a ton of really cool videos like this that they're posting all the time. And if you like what we're doing here, maybe you'll enjoy watching some of the other videos as well. Also, I work for a company called Veritas. We do a lot of great things, so if you enjoy what we're doing, I hope you'll check Veritas out as well. So today I'm hoping will be kind of a fun one, a little bit more scattershot than my previous single topic couple. The last couple I was really focused on delving deeply into a single topic like number theory or Diophantine equations. Today I decided to do something just a little bit different. Again, it's a math presentation, but I decided that I think perspective is so important, and I know so many fun problems that involve just maybe looking at things in a slightly different way. I've seen some in the official guide. I've written my own versions of some of those problems. And students often struggle to see them in the right way. And I just wanted to give you the opportunity to maybe look at them from a different perspective and see them how I see them, and understand how that can make your GMAT life a lot better. So that's Wait, It's Not What It Looks Like. And I think we're going to kind of jump in pretty quickly. I'm going to show rather than tell what I mean by this. So mental flexibility, critical skill, ability to look at a problem from different perspectives. I think I mostly said all of this stuff. Why don't we look at a problem that there are different lenses through which you can see this problem, and this problem can be as hard or as easy as you make it. So we'll see who finds the hard ways and who finds the easy ways. But I'm going to go ahead and ask that you do this problem. Now, to do this problem, we have a poll link that you can follow. It's this poll link right here. Whoops. It's okay, apparently I can't write on this page. Something is up with my pen. Let's try that. Hang on just a minute. Okay, there we go. Let me try that again. I still can't write on that, but anyway. Minor technical difficulties. Thank you, GMAT Club has shared the poll link. Anyway, I'm going to give you guys 2 minutes to do this question, although if you find the right way, you shouldn't need nearly that long. And what I'd like you to do is do this question and put your answer in the poll at that link. Please do not, under any circumstances, shout out your answer in the chat. Don't ruin it for people. I don't want any answers in the chat. I do, however, want all the answers in that poll link right there. You have 2 minutes. Please go ahead. The poll should be opening soon. All right, we just hit the 2-minute mark. I have very few answers in my poll right now. We have a lot of people watching, so now's a good time to put your answers in that poll. I'd like to get as much participation as possible. If you're not sure, take your best shot. Give me what you think it is, but so far I think I have, it looks like, sorry, I'm checking the poll on my phone, 4 of you? It looks like 4 of the 28-ish people watching have partaken in my poll, so please do so, and in a moment I will show you the very fun looking answers that we have so far. But last chance to get in on this. It can be. That's the interesting thing about it. It can be as tough or as easy as you want it to be. Tell you a funny story about this. So I'm going to go ahead and show you the responses. These are the responses that we have right now. Continuing to live update, but obviously from this point on they'll all be a little bit spoiled because you guys are now biased by what you've seen other people pick. A little bit of a fun story about this. I was trying to write an easy problem, and that's actually something that I'm bad at. I'm demonstrably bad at writing 500 level GMAT problems, and it's not that I don't try, sometimes I do. And I thought, oh, well, I see this from a certain perspective. It's very simple. It'll probably be like a 500 to 600 level problem. It ended up percolating up on the GMAT Club, and it has actually been up in the GMAT Club forums for some time now. And yeah, it's a 95th percentile hard question. Oops. But that shows how important perspective is. Because when you look at the solutions on GMAT Club, I'll show you what a lot of them look like. Okay? And I'm not going to tell you the answer yet, but you're going to find out. Here's the question again. Vladimir plays a game, he reveals cards. If he gets a heart, he wins. Diamond, he continues. Club or spade, he loses. We just want him to win the game, right? It's very simple. Just probability he wins. So here's what a lot of people do. They go, okay, well, so the probability he wins on the first card, which is a heart, is 1/4. Okay? And then they go, okay, well, but wait, he could also win on the second card because he could get a diamond and then he could get a heart. 1/4, and then there would be 13 hearts left in 51 cards, 13 over 51. Or maybe, no, he could win on the third card, diamond and then another diamond and then a heart, etc. I'm curious, did anyone try to do this? Did anyone do something along these lines? They kind of go, okay, so the total is this plus this plus this plus blah, blah, blah. Was that anyone's approach here? Yeah? Kartik and Div? Anyone else want to admit to that? It's okay, no shame. A lot of people in the forums did that. A lot of very smart, high-achieving people tried to go down this path, and some of them even made it after, I imagine, just a whole bunch of agony and pain and strife. Some people managed to make it through this horrible path. And of course, if you do the 1 minus he loses, you're right, that's not any better, by the way, because then the probability he loses on the first card's 1/2, but then maybe he gets a diamond, then he loses on the second card, and then maybe it's diamond, diamond, he loses on the third card. So complementary probability won't save you here, okay? So how else could we think about this problem? Well, what you're doing is you're looking at all of his picks, all of the cards he pulls, starting from the first one. But isn't it true that the only card that really matters is the last one? Doesn't really matter. No, that's not it either, Jeet. Sorry. That's like saying, I'll either be struck by lightning on my way home today or I won't be struck by lightning. So 50-50. The loss is 1/2 just on the first pull, but it's not 1/2 overall because he could also lose later. Do you agree that the only card that really matters is the last one for Vladimir? Just the very last one he pulls. Nothing matters until then. He can pull all the diamonds he wants, but eventually he's going to pull a heart, a club, or a spade, right? One of the three. That's true. Do you agree with what I just said, though? Do you agree that eventually he's going to pull a heart, a club, or a spade, the game will end, and that is the only card we actually care about? You don't agree. You do agree. Okay. Roberto agrees. Christy agrees. Okay. Kartik, why don't you agree? I would argue that he could pull all the diamonds he wants, but eventually he's going to pull something else. Eventually, doesn't he have to pull a non-diamond? I mean, he's going to run out of diamonds sooner or later. Even if he pulls all 13 out of the deck, eventually he'll pull something else. It is a lot of cards, right, but, do you agree that sooner or later he's going to pull a non-diamond? Do you agree, Kartik, that sooner or later he's going to pull a non-diamond? And when he does, the nature of that non-diamond, whether it's a heart, a club, or a spade, is the only thing that determines whether he wins or loses, right? Nothing else but whether the last card is a heart, a club, or a spade. So then let's stop focusing on all of the other cards that don't really matter. Let's just talk about the last one. What's the probability that he wins on the last card that he pulls? How many cards could be the last card? And how many of those cards that could be the last card would be winners? And remember, the only thing we know about the last card is it's not a diamond. There are 13 hearts, there are 13 clubs, and there are 13 spades according to the problem, right? So how many winners are there and how many total cards? "13 winners out of how many total cards?" Well, not out of 15. First of all, it's not 14. No. The last card is not a diamond, Kartik. You got to get the diamonds out of your head. What I'm trying to argue is the diamonds don't matter. You guys, some of you are getting it now. Jeet's got it. Swapnil's got it. There are 39 cards. Kana's right. And as Kana also said, there are 13 winners. And Christy is right about that as well. The last card is going to be a heart, a club, or a diamond. That's heart, a club, or spade, excuse me. That's 39 cards. And among them, the hearts are winners. That's it. He wins a third of the time. If the last card's a heart, he wins. If it's a club or spade, he loses. He has a 1 in 3 chance that the last card's a winner for him. And that's the whole calculation. There is nothing else you need to do for this problem. The diamonds don't matter. Another way to think of this is, if I took all the diamonds out of the deck and lit them on fire, I would be no happier or less happy to play this game as Vladimir. It doesn't make me any better or worse off. Can you see it from that perspective? Who has questions? Who has comments? Great, Critty. Sorry, Creedy. I'm sorry. I apologize, by the way, if I'm mispronouncing anyone's names. Please forgive me, stupid American over here. Creedy, I apologize. But yes, if you want to correct me, feel free to correct me on your pronunciation in the chat, and I'll try to get it right going forward. Does everyone follow this, or does anyone have questions? Let me know if you follow. Let me know if you have questions. And then if you have questions, I'll address them. Otherwise, I'll move forward. And, we'll talk about it. We'll take some takeaways from this. We'll try another problem. You get it. So, the real key to this problem was to stop fighting it. If you sit here and you say, I'm going to do this, you're missing the point, right? The GMAT doesn't care about this, right? This is not what the GMAT wants to test. The GMAT is not actually interested in your ability to lay out ridiculously long, ridiculously grindy calculations and then execute on them. Some people say, well, I know the infinite geometric series formula, and this is almost an infinite geometric series. The GMAT doesn't even care about that. It doesn't need you to know the infinite geometric series formula. I know there's some people in the forums on this problem who are solving it that way. It's pointless. It's completely not necessary, and it's just not what this is ever supposed to be about. So if you find yourself really struggling, then rather than spend those 2 minutes fighting out futilely with that ridiculous approach that you're using, step back and spend those 2 minutes trying to look at how else you can see this problem. Well, looking at the first card and the next didn't work. What else could I look at? I could look at the last card. I could look at what the diamonds really matter if, after all, they just mean try again, try to see the problems from different perspectives, and know that one of those perspectives, at least one of them, is guaranteed to be a better way. There's always a better approach out there, and that is so much more your job on this test. Your job is not to fight it through the hard approaches. Your job is to find the better ones, okay? And let's see if we can do that again. All right, here we go with another problem that maybe isn't exactly what it looks like. So I'm going to reset my poll, and then I'm going to give you the same exact poll link, because all my polls are just at the same link. And you can go to the same poll link. Perhaps GMAT Club can repost it for us. And you can put your answers into the poll for this question over the next 2 minutes. I will walk off for 2 minutes and give you a chance to answer in the poll. Again, please answer in the poll and nowhere else. So we're at 2 minutes. I'm checking the poll to see how we look. And again, we don't have very many answers in here. Just a couple. What's up, guys? Let's get the answers in. In the poll, please. Nowhere else. Follow the link to the poll. Post them in the poll link. It's very simple. Just follow that link. Pick your answer on that link. Okay? Please? Because if you put them in the poll, I can display them up on my screen. Everyone can see the statistics on that. Plus, you won't bias anyone by putting your answer in the chat. So just post in the poll. Okay, so I suppose I've got most of what I'm going to get. Thank you those of you who did just move your messages over to the poll. And again, Monica, please put in the poll on the link. And all right, so let me show you now the poll results that we've got so far. We got about a dozen of you voting. I appreciate it. Thank you to the roughly dozen people who participated in my poll. And here's what the results look like. Live, as we can see, some people shuffling around their answers back and forth, maybe a few other people adding in. So, a lot of B's and a good handful of D's. A lot of people said 11, got a 19, got a 67, got a few 23s. Now, in terms of how people approach this, I think that one thing that people do is they simply prime factor all of these and they just look at, well, what's the greatest factor in any of them? And you know, there's an 11. How's my pen doing that thing again? Ugh, okay. There's an 11 in here, and there's actually an 11 in there, And that's the biggest single prime factor that's in any of these terms. The problem is there's not an 11 in here, okay? And so, in fact, what I can tell you is that means there's definitely not a factor of 11 in the whole thing. Because one of the rules we know about number theory is that any multiple of 11, right, any multiple of 11 plus a non-multiple of 11 will not be a multiple. Now, if you don't know that rule, you may want to go back and watch my presentation from some time back. You can find it on the YouTubes, as the kids say these days. You can find it on the YouTubes called Thinking Like a Number Theorist, and that's one of the rules that I taught you. One of the rules I taught you is that if you have a multiple of some number, and that's a multiple of 11, and you add a non-multiple, the result is not a multiple. So certainly, I'm not going to be a multiple of 11. And by the same exact logic, I'm not going to be a multiple of 5, because there's a 5 there, there's a 5 there, but there is no 5 there. Now, I'm curious whether anyone decided that brute force was the answer to all problems. Did anyone go, okay, well, what I really just need to do is frickin' calculate. I can just do the math, you know? 25 squared is 625, 44 squared is, oh God, I guess it's 1936, and, you know, I could add this all up and get 4761. Kana did that. It's okay, Kana. It happens, but remember that the goal here is to find a better way. You just added 625 and 2200. Okay, but how does just adding those help you? Unless you put in the 44 squared, I don't think that does you a whole lot of good. All right? Yeah, now Abhishek, hold that thought, okay? Hold that thought. So now look, I could be a total masochist, and I could take that and I could get 4761, and you think the worst is over, you're wrong, because now I got to look at 4761 and prime factor, and I got to go, okay, well, it's a multiple of 3 and 9, and factoring gives 9 times 529, and perhaps I recognize 529 as 23 squared, so apparently it's 3 squared times 23 squared, and the greatest prime factor is 23. And if I were a total masochist, that's definitely how I would solve this problem. But if I were not a total masochist, I would try to see this in a different way. And one of the ways that I would get there is I would say, well, what is this really about, right? Like, do they really want me to sit here and do all of this calculation, right? No, absolutely not. They don't expect you to sit here and do all this calculation. So what is it that they're really testing? What was the test maker thinking when they wrote this? And why did they write it this way? And this is where Abhishek is absolutely right. They wrote it this way because they wanted the clever among us to realize that this looks kind of familiar. Something squared plus something else squared plus another term. Well, doesn't that kind of look like a squared plus 2ab plus b squared? One of our special quadratics that I hope you all know, right? You already know this quadratic. Doesn't this kind of look like that? I mean, I guess I'm not sure. The real question would be true or false. Is 2200 equal to 25 times 44 times 2? True or false, 2 times 25 times 44 equals 2200. And actually, yes, that's true. 2 times 25 is 50 times 44, which, if you're clever, is 100 times 22. Right? Multiply the 50 by 2, divide the 44 by 2, doesn't change the total value. And the result is 2200. How can I help, Matt? Matthew? You said you're a little confused. Is there something I can clarify for you? Certainly don't want people to be confused. So speak up, let me know what you're not following. But you guys do know this rule, right? You guys have seen the rule, a squared plus 2ab plus b squared equals parentheses a plus b squared, yes? All right, well, if you come up with a question, I'm happy to answer it. I certainly don't want anyone to be confused. So again, what is this problem really about? It's never about calculation. It's about recognition. What do we do next? That's a great question. Well, what do I have here? What I have here, 25 squared plus 2200 plus 44 squared is this. So what do I do next? I take this and I make it look like that, right? We now know that what we have here is simply this, which is this. It's 25 plus 44 quantities squared. Right, Nagrajan? Do you agree with that? At which point, exactly, it's just 69 squared. I can factor 69. 69 is 3 times 23, and so that's 3 squared times 23 squared. And look, I did it. There's the greatest prime factor. We're done. So what do you think about that? Was that a better perspective in which to see this problem? Good. By the way, in case you think I'm a crazy person who writes ridiculous, unrealistic problems, I'll let you know that this problem was closely inspired by an official guide problem. There's an official guide problem that, if you want to look it up on GMAT Club, involves the number 0.999999991. Now, if you look that number up on GMAT Club, you should find the problem I'm talking about, which is also a 95th percentile hard question from the official guide, and very much the same thing. It takes numbers, actual calculational numbers, and makes you recognize the special quadratics within them. So having that perspective is absolutely something that the test maker cares about. Now, what if the perspective doesn't dawn while solving? Well, oh, thank you, Aditya. If this perspective doesn't dawn while solving, well, that's not always going to happen. You're right, I get it. It doesn't always happen for me, it doesn't always happen for anyone, and the answer is you're going to have to grind some of these out, and it's going to suck. And you may just miss some of these, and it's going to suck. I don't always see the right perspective either, and I end up having to grind them out. But here's the thing. What today is about is inspiring you to look for this more often, and trying to show you how to see it a little bit more often. Please add the question on top. The one that I mentioned from the official guide. Yeah, I'll try to put a post in there after the lesson. I'll put a post in the chat. Yeah. Anyway, sorry, I've lost my train of thought for a moment. Yeah. So look, this lesson is about helping you think that way more often. And each of these problems, I'm going to give you a tip about what you can try to do, how you can try to think that might inspire this shift in perspective that you need. And no one's going to get it every time, but the more often you get it, the better off you will be. Yeah, these will all be in a link. We'll definitely post the slides here in a link so that everyone has access and everyone can download them after the class, okay? Okay, Akshay? Everyone will get them. So yeah, again, it's tough right now to say, hey, you're not always going to get this, but the goal is just to maximize. The goal is just to get it as often as you can, and the more often you get it, the better off you'll be. And in your practice, this is something you should work on doing. You should hone and cultivate your mental flexibility. This is a skill that we can develop, and it's just a matter, to some extent, of making a point of developing it, of saying, hey, my perspective is I'm not going to go that horrible route. I'm going to spend the time instead trying to find a better one. So don't ever do hard arithmetic here. And the key insight to this problem was thinking like they do. Why did they write this problem? How did they come up with these numbers? What could have been their purpose? What do we know that they could have been testing? Because I assure you that what they weren't testing was how well you square 44, add it to 2200, add it to 625, and then prime factor. Guaranteed not what they're interested in. So let's do it again, and I will show you. Is there an exhaustive list of patterns? No, because the test makers are always coming up with new ones. You know, it's kind of bit of an arms race between us tutors and them test makers, you know. It's a friendly competition. They're always coming up with new things, and we're always trying to play guessing games, figure out what they could do next. But I think that rather than try and memorize a list, again, the goal is to learn to just turn these things over in your head in different ways. Okay? And this next problem is a great example. I'll tell you, this next problem is one that the first time I did it the worst possible way. I mean it. I spent 3 minutes, I grinded it out. It was absolutely miserable. I did eventually get there, but it sucked, you know? And I'm sorry, what is the IOD of actual GMAT compared to the latest OG? I'm sorry, I'm not sure. Sorry, not sure. But this is a great problem, and hopefully you'll do better than I did, because when I did it, it was horrible. LOD, level of difficulty. Well, the whole thing about the official guide is that it's not adaptive, and your test is, so it really depends how you're doing. You know, if you're doing very well, the actual test will end up being harder than the official guide. If you're doing not so well, it'll be the other way around. If you do need harder problems, they just came out with an advanced guide this year, may be worth checking out. Anyway, let's try this problem. I'll give you about 2 minutes to get it done. Poll is going to be open. Should be the same link as before. Perhaps GMAT Club can repost that link for us in a moment. Answers in. Okay, put them in the poll, please, in the actual poll link, Akshay, and everyone. Don't want to spoil it for anyone else, and we do want to be able to show the stats and have them be accurate. So, Akshay, want to jump in the poll? Last chance, I'm going to show the results. Okay, so this one went a lot better. It's actually a little bit of an easier question. This is more like a high 6 to low 700 level question rather than the mid to upper 7s. Why is geometry what? Excuse me? I don't know. There's the results. Now, you know, the real key here is not just to get there, but hopefully to get there in the best possible way. And I will tell you, the first time I did this, I didn't exactly choose the best possible way. So you say, what happens if you don't see the better way? The answer is your life will be pain for the next 3 minutes. And my life was. Because when I looked at this problem, I said, well, okay, first of all, I've got the 5 here for sure. Everyone knows that's 5. But then from there, I'm going to do the Pythagorean theorem. And I know that, I don't know the sides of the smaller triangles, but that's never stopped me before. I could just label an unknown. I call that y, call that 5 minus y, and bad spot on the board there. Okay, and then I could just kind of go nuts on it. Do the Pythagorean theorem, call the length I'm looking for x, and x squared plus 5 minus y squared is 16, x squared plus y squared is 9, and I could just, I could FOIL that out, and I could subtract them, and I could solve for y, and I could plug it back in, and I could then, take a common denominator of 25, and I could subtract again, and when I subtracted again, I could take the square root, and finally I could get it. X is 12/5. Right? And it sucks. And I'm wondering if anyone tried to do it kind of that way. I hope not, but I'm probably not the only one out there who's ever made that mistake. Now, if not, maybe, I don't know. Yes, no? Okay, I guess you guys are better at this than I am. Good for you. Way to go. Maybe some people tried to look at angles. Now, one mistake that people make is they play... Yep, okay, so yeah, you guys are way ahead of me. I'm getting there. One thing that people do is they try and play guess the angles. They go 45, 45, 90 or whatever, and no, it's not. It's not a 45, 45, 90 triangle. Just because this line goes to the hypotenuse, even because it's at a right angle, that doesn't mean it bisects. But I could certainly play guess the angles, call that A. 90 minus A, you solve for that one and it's A again. That one's going to be 90 minus A again. And I could go, ooh, look, similarity. All of these triangles have all the same angles. A, 90 minus A and 90, A, 90 minus A and 90, the big one, A, 90 minus A and 90. And I could do the similarity, and I could be like, okay, well, this little triangle on the left has a hypotenuse of 3, and the big one has a hypotenuse of 5. The little triangle on the left has a leg of x, and the big triangle has a corresponding leg of 4. So, x is to 4 as 3 is to 5, and again I could go x is 12/5, and again I'd be exhausted. I'd be exhausted at the end of 3 hard minutes doing this problem, and probably be a minute behind. But it would work. I could do it. But again, the point that this lesson is making is that if you can get a better perspective, your life will be easier. And the funny thing about this problem is that when I say that you need a different perspective, I mean literally. So sometimes what you need to do is just say, well, what else could I know? They asked me about length. I tried to leverage lengths. It was a disaster. I tried to leverage angles. It was no good. And maybe you say area, and I say area. What the hell does that have to do with anything? That's got nothing to do with this length at all. But whatever, man. Just go with it. Just see what happens, Because who knows what the right perspective is going to be. Sometimes you just have to lay it all out there. Think about every way you can look at the problem. Now, I assume you all know that the area of this triangle is 1/2 base times height. And with a base of 4 and a height of 3, I assume you all know that the area is 6. This does not come as a surprise. This does not come as a surprise to any of you. Am I right? Okay? All right. Now, as I was saying, the funny thing about this problem is that when I say you need a different perspective, I mean literally. So what I'm going to do now is I'm going to pick up my board and I'm just going to... Oh, it's heavy. I'm just going to turn it. I can't. I'm sorry. I tried. So it's too heavy. You'll just have to stand on your heads, or maybe I could just use my magical pen and I could just turn it, Ooh, look at that. Magical pen. Okay, so now I turned the triangle by magic. So what's the area of this triangle? Before I turned it, it was 6. How about now? Come on, you know the answer. Still 6? Okay, sure. Yeah, I turned it. It didn't get bigger. It didn't get smaller. The area is still 6, right? But of course, what's the base of this triangle now? Right, Kriti, right, Krishna. What's the base now? Well, no, the base isn't the same as earlier. The base is 5, right? Now this is the base. The base is 5. And what's the height of this triangle? Right, what's the height? Height. Yeah, the height will be x. So if you're telling me the area is 1/2 base times height, well, that's the area. But of course, that area is still 6. Well, okay, then I guess x is 12/5. And I saw this solution, and I proceeded to smack myself in the forehead as hard as I could. I couldn't believe it. I just wanted to die. I was like, oh my God, I did all that work, and this was it? And yeah, sometimes it's going to be like that, and sometimes you're going to end up having to feel that way. But obviously, the more that I could have found the better perspective, the better off I would have been. And again, that's the point of the problem and the lesson. So how do I get the better perspective this time? Well, with geometry, the better perspective can be a very literal thing. Just literally try to turn them around, see them from different sides, see them in different ways, focus on different angles, and yeah, and just try to list everything you know about it. Try to think about, okay, well, length wasn't very good. How about angles? Okay, not very good. How about area? I don't know why it helps, but maybe, whatever. Just try to get new things to work with. The more different ways you can see the problem, the better the chance that you will come across the easy one. And again, the reassuring thing to know is just that it is there somewhere. There is the easier way. So it's not going to be in vain if you put in that effort. Don't feel stupid. Hey, look, man, I scored 99th percentile on this test, okay? I didn't give a proper introduction at the beginning. I'm sorry, I just completely slipped my mind. My name's Anthony. I got a 790, okay? I'm a professional GMAT tutor. I've been doing this for almost 20 years, full-time for over 10, and I didn't find that way the first time I did it. No one's going to see it all the time. Don't feel stupid about it. Just learn from it. Just learn to see the problems in new ways, you know? So, sorry, I should have introduced myself at the front. Yeah, anyway. Hi, I'm Anthony Ritz. It's nice to meet you all. I'm a GMAT tutor for Veritas. I have a 790 on the GMAT. I've been tutoring for almost 20 years. Helped students go to pretty much every top school. So again, how do we develop our perspective? Well, every question has tips about that, right? There's no singular answer to that 99 investment ideas. And here's some tips. Try to leverage information, even if it seems irrelevant at first. Try to find hidden relationships. Think about what else you could know. And with geometry, sometimes when we say you need a different perspective, you mean literally. You turn it, you look at it this way, you look at it that way, you stand on your head, etc. And maybe standing on your head is what you needed to do for this problem, right? Let's keep going. We got a couple more. I've got 3 more problems in the slides. In the interest of time, I'm probably going to skip 1, but I do still think I want to get to 2 more before I run out. That was my first ever score, Akshay. I only took it once. I'm actually due for a retake. I want to see if I can get the 800. But yeah, that was my first and only GMAT score. Okay, so let's go again. Yeah, this one's fine. So we'll do this one, and then I'm going to skip one, and we'll do the last one. Again, I'm going to give you 2 minutes. Again, I'm going to give you a poll. Let's see what you do here. Clearing responses, go ahead. All right, again, we come to the 2-minute mark here. And again, I take a look at my poll. And okay, I got seven responses so far. Anyone else? Anyone else? All right. Good. So this is going pretty well. And see, now I'm really regretting that I didn't get to my other problem. I don't know. Maybe I can squeeze it in if I hustle. We'll see. I don't know. I got 2 more. I don't know. We'll find out. So one thing you could do here is you could just literally grind it out. You could say, okay, so you want the function rule, f of a minus b is f of a over f of b. Well, let's just try them all and see if it works, you know? What if it's x cubed? Oh, by the way, here's the poll results. So a little over 50% for D, good number of E's, C's, an A. Yeah, poll results. Great. And thank you. Again, I really appreciate your participation. I think it's wonderful to be able to kind of show the results and see where people's heads are at. It's much better this way, I think, than if everyone just kind of sits silently and I just monologue for an hour. Okay, so I could just start plugging in. You know, I could just go, okay, whatever. If f of x is x cubed, f of a minus b is a minus b cubed, f of a is a cubed, f of b is b cubed. Is that true? No, that's not true. Okay, how about this one? Do the work, blah, 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 blah. Is that true? No, that's not true. This horrible one, f4x over 3 minus x, geez, I don't know. You sit here, you do all this work, 4a minus 4b over 3 minus a plus b, 4a over 3 minus a, 4b over 3 minus b. Plug it all in, you get that, and maybe you even have to do a little more manipulation before you can finally say, no, it's not it. Doesn't work, okay? It does not give you the same thing. Finally, you go to this one, and you plug in, and you're like, does it work? Actually, yes. Yes, it actually works. And you can stop. You don't even need to check E. E does not work, by the way, if f of x is -1. I did get a few people on that, but this would be -1 equals -1 over -1, which is -1 equals 1. That's actually never true, right? -1, -1, -1. They all be -1. That's false, right? Super false. But that was a pain. So again, the question is, how could we have done it better? And the answer is, it's funny because I called this wait, it's not what it looks like, and then I realized that one of the strategies that I wanted to teach you was, think about what it looks like. Oops. So maybe not the perfect name for the presentation, but think about what this looks like, because again, are they really testing your ability to grind it out with 5 different answer choices plugging into a function? Probably not. Maybe what they're testing is your recognition of what this looks like. So think about the functions you know. What's a function that turns subtraction into division and vice versa? What's a function that when you divide it by itself, you just end up subtracting? And DebDeep is our winner here, because DebDeep said the magic phrase, said exponent rules. You guys all know this exponent rule, right? You're familiar with that, aren't you? When you divide exponents, you subtract the powers. And here's the thing. If you go, wait a minute, f of a over f of b, get that bad spot on the board again. You get that fixed. Sorry about that. It's f of a minus b, and you compare it here. You go, wait a minute. It's the same thing, right? Notwithstanding the board being a little bit wonky, it's the same thing. You know, it's the exact same rule. And so, wait a minute. All I really need to do is figure out which one of these answer choices is just an exponential function. I wonder, is there an answer choice? Is there an answer choice that is an exponential function? Well, why there is, actually, d. d is f of x is 2 to the negative 3x. Let's just check that one. We'll skip all the others. We'll just plug that one in right away. Does it work? It works. Great, we're done. You save yourself, you know, 3/4 of the time, something like that, by identifying what you're looking at, by recognizing it, and then checking that it works. And again, that's another way to get a better perspective and save yourself a lot of grief here. right? This looks like a function problem, but it's really an exponent problem wearing a funny hat. And I know something about people wearing funny hats, so trust me when I say that. Any questions here? Okay, can I go a little more than an hour? Would you guys be cool with it so I can squeeze in both of my remaining problems? I'm going to try and squeeze them both in because I think they're both fun. So we'll probably run a little longer than an hour here if that's okay with you guys. Can you hang around? Yeah, you'll hang around? Absolutely. Okay, great. Free extra tutoring. My free tutoring is going to be more free tutoring. So look, it can be useful to consider what a problem looks like. And again, in terms of getting different perspectives, what does this look like? Now, granted, if you consider what it looks like, and you say, oh, this looks like this, you still have to back it up and prove it. It was important to note that I didn't just say, oh, it looks like an exponent, pick D, move on. I said, oh, it looks like an exponent, check D, D works, now I know, move on, right? So it is important to not skip that step. But if you don't skip that step, it can be useful, again, to just get a different perspective to kind of look at what it looks like. And by the way, in this problem, it was what it looked like. Even in the cases where it's not exactly what it looks like, sometimes that exercise can still be useful because sometimes even understanding how it's different from what it appears to be can give you some useful insights. Sometimes if you're able to say, okay, well, it's different in these ways. This is how it's different, and this is why that matters. Then even that can give you the insight you need to get to the better perspective. So I don't have a problem with wrong answers as long as you use them for something. As long as you learn from them, even within the problem you're doing, a wrong answer can be a very valuable thing. Okay, couple more. Here's the next one. Pretty hard, I think. World debut, world premiere of this problem. We'll find out how hard it is. You have 2 minutes. I'm resetting the poll. Should be the same link again. So scroll up for it. I'm sorry, I hope GMAT Club could maybe throw it in there. But same link. Please vote in the poll. Not in the chat, just the poll. Okay, so we're over 2 minutes. Yeah, sorry guys, I don't actually have permissions to post links in the chat, so I'm not able to post them. But again, it's going to be the same link each time. I just clear the poll and reset it basically. So let's get the answers into that poll. right now so that we can, in fact, discuss this question. And sorry that it took an extra minute to get up there, but yeah, answer in the poll. Okay. So either these questions are not as hard as I thought, or you guys are very smart. I'm going to go with you guys are very smart, because that's the nice thing to say. And I think it's true. You guys seem to be doing very well here. So yeah, people did very well with this question. But I wonder how they did. I wonder how many people just sort of decided to grind it out and just try some values of x and be like, okay, what if it's 1? What if it's 2? What if it's 3? What if it's 4? What if it's 5? And that could be very tedious, right? Like maybe you can get there that way, but it's a bit of a pain. And don't you always have to kind of wonder, like, am I sure I found everything? Am I sure I got all of them? How do I know I didn't miss one, you know? Yeah. We're getting there. Absolutely. Okay, so obviously you guys are just very smart. Kana, Debdeep, you guys are way ahead of me. Here's the results. Okay. Yeah, no, we're going. So look. If we started out saying, oh, it looks like an exponent problem, we factor it out, you know? Prime factor the bases, whatever, we do that. We replace the 4 with 2 squared, and then we go, okay, well, I can algebraic factor, I could pull the 2 to the x out of this, and I could tally it up, and I get about this far. I get 2 to the 2x minus 2 to the x times 12 plus 32 equals 0. But, you know, if you try to keep doing exponent stuff here, just straight up exponent properties aren't going to help you. So how do we handle it here? Well, maybe, as several of you noticed, we look at it and we say, well, this looks like an equation not in terms of x, but instead of terms of 2 to the x. So what if we just replace the 2 to the x with a different variable? What if we call it, you called it y, Debdeep, I chose a. What if we said, okay, well, let's just replace it with a, at which point it's worth noting that 2 to the 2x would be simply 2 to the x quantity squared, so that would be a squared. The equation would be a squared minus 12a plus 32 equals 0. Now, wait a minute. It's a quadratic equation, right, as several of you told me. How many of you recognize the quadratic equation? I already know about Kana and Debdeep and Kriti. Anyone else? Did other people see this? You really are terribly clever, all of you. Great job. Very good, Sumit. Excellent. Yeah, Nikhil. Okay. Well, obviously I need to come up with harder questions. I am, I'll go back to the drawing board for the next time, try and come up with some 800 level questions, because 700 is not hard enough for some of you guys. Okay. Well, bamboozled. All right. Well, now, it's a quadratic. We can factor the quadratic. I'm looking for two numbers multiply 32 and add to 12. Those numbers are 4 and 8. And I'm going to factor it as such. A minus 8, a minus 4 is 0. So a is either 8 or 4. Well, I flipped that around. 4 or 8, 8 or 4, whatever. It doesn't matter. Same difference. All the same. I don't know why I reversed the order there. But 4 or 8. But be careful here, because, of course, that's not the question. The question is not what is a. If you transform in this way, you need to transform back, because ultimately the question was about x. So that means either 2 to the x is 4 or 2 to the x is 8, at which point x is either 2 or 3, at which point we're done. The sum of all possible values is 5. Yeah, you can say left hand equals right hand with guess. Yeah, it's not foolproof. You just have to be hoping that you didn't miss anything. Hope that there's no, like, what if it's a non-integer solution or whatever. Like, you can guess and check this one, but I think it's helpful if you recognize what this is. And in this case, the moral can be just to transform your algebra. Try and rearrange it. Relabeling unknowns in some cases can even simplify something and reveal new ways of looking at a problem. Just if you do that, make sure you transform back at the end, because of course the question is never going to be what's the value of this new variable a that you invented. It's going to be, you know, what was the original variable x or something like that. Okay, I'm going to try one more time to come up with something hard enough. And this is another one that has been up on GMAT Club. So one more problem, GMAT Club. Hang in there. Don't close me out yet. Don't close me out yet. I am actually doing a class on verbal akshay at the end of the month. I'm going to do one on sentence correction. Yeah, I'm going to do the intersection of meaning and grammar, I want to say on maybe the 29th of the month. Okay, so check the schedule for that. I will be back, and yes, I will do some verbal with you. Last one, I'm going to reset the poll. GMAT Club will hopefully post the link. No, this is the last one I've got, Praveen. I've just, we'll do this and then we'll close it out, okay? Good luck. Okay, let's get those answers in. I've only got like 6 of you. 6 of you so far. Who else? Who else wants to play with us? Come on. Take your best shot. Yeah, that would be great. I would love it if you got the right answer by taking a different perspective, Nikhil. And that, by the way, is very common in combinatorics, especially. So many combinatorics problems. I mean, I thought about just doing like a combinatorics lesson on this, and I could have easily just given like half a dozen different combinatorics problems, all of which just had the different perspective angle to it. I decided I wanted to mix it up and give just a whole variety of areas to show that it's not just one place that this matters, but it's a huge thing in combinatorics to find a better way to look at the problems. And let's talk about what that could be. I wrote this problem for Veritas, and again, if you like us, check me out at Veritas. I do classes over there. Check us out. We're a great company, if I may say so. I wrote this for my boss to take a look at, and he took a look at it, and he did it the worst possible way, and he ground it out. He's like, "Oh my God, Anthony, this is so hard. I don't think this is reasonable for the GMAT. I don't think we can ask this question. It took me like 3 minutes, and my boss is a 99th percentile test taker." Right? Yeah, so we've got some great deals right now. Definitely check us out. We've got some good online classes and some discounts on those. So anyway, my boss was like, I don't think we can ask this question. It's too hard. So let's see, what did he do? Well, he said, oh, by the way, here's the results. Yep, results right there. Okay. So he said, well, let's see. Mel could get no marbles, 1 marble, 2 marbles, 3 marbles, 4 marbles, 5 marbles, or 6 marbles. And of course, Nora would get whatever is left over. This is the easiest of the lot. What I would say about this, Seshwat, is that they're all the easiest of the lot if that's the question you saw in the right way. For every one of these questions with the right perspective, it's trivial. But getting the right perspective is the hard part. So I am not surprised if a lot of people would have a lot of different answers if I asked you which was the easiest question here and which was the hardest. Because the answer is the easiest is the one that you happened to see the right way, and the hardest was the one you didn't. And the more that you can happen to see these things in the right way, the easier your life will be. So I'm guessing Seshwat found the short way for this problem. But this is not it. Because here you could go, well, Mel could get 0, 1, 2, 3, 4, 5, or 6 marbles, and if it's none, that's one way, and if it's one marble, it could be red or blue or green, and if it's 2 marbles, it could be red and blue, or red and green, or blue and green, or red and red, or green and green, or whatever, right? Yeah, we're getting there, okay? But like a lot of people do that. I'm curious, did anyone try and do this approach? Did anyone try and say, okay, well, what if it's no marbles? What colors could it be? What if it's 1 marble? What colors? What if it's 2 marbles? You know, red and red, green and green, red and green, red and blue, blue and green. What if it's 3 marbles? Did anyone do that? Did I catch anyone going down that path? And you want to admit to it? Yeah? Yeah. See, I'm not surprised. Again, even my boss, who's a 99th percentile test taker, did. And Nikhil said that occurred to you, you tried to take another look at it, which again, I appreciate so much. But yeah, this is hard. You found the other way, and that's amazing. That's fantastic. So what is the other way? Well, instead of trying to focus on how many marbles Mel gets and like what colors are the ones Mel gets, what if I just said one color at a time? Let's just talk red marbles. How many choices could Mel have for red marbles? Well, Mel could have no red marbles. Mel could have 1, or 2, or 3, right? Do you all agree that Mel has 4 possibilities in terms of red marbles? You don't agree. Why not? Shashita, what don't you agree with about this? Do you agree that Mel could get 0, 1, 2, or 3 of those red marbles? Because there were 3 red marbles. Sorry, Sahitya. I'm sorry if I'm struggling with some of these names. Sahitya. Did I pronounce it right? What is it that's bothering you here? I'll let you type up, and as soon as you get your comment typed up, I will respond to you. In the meantime, I'm going to go ahead and talk about the green marbles, right? Talk about the green marbles. But please, if you're not understanding something, explain what you don't follow, and I will talk more about it, okay? I want everyone to understand what we're doing here. So, green marbles. There's 2 green marbles, so you could get 2 of them, but you might not. You could get 1. You could get 0. Yeah, Akshay, we have some other people watching. I'm quite certain that we have some people other than South Asians in here. I think that the GMAT Club audience, there's a lot of South Asians, especially at this time, because the time that we're doing it I know is late evening for South Asians. It's middle of the afternoon for US audience, so a lot of US audience are at work right now. So that's probably why the breakdown is a little bit the way that it is. You didn't get to this. Do you understand it, though? Do you understand it now that I'm showing it, Sahitya, why you would have 3 options for what number of green marbles Mel gets? And then finally, why you would have 2 options for the number of blue marbles Mel gets. Mel could get no blue marbles, or Mel could get 1 blue marble. Right? Everyone follow? And finally, Mel gets some number of red marbles and some number of green marbles, and some number of blue marbles. And by the way, I'm not worried about Nora. I don't care about Nora. Why? Because she gets the rest. Whatever Mel gets, Nora just gets whatever is left over, if anything, right? So we could just count Mel, and that's good enough. So I count Mel, and I multiply, because one of the fundamental principles of combinatorics, the basic counting principle, says and means multiply. She's getting some red marbles, and some green marbles, and some blue ones. We take 4 times 3 times 2, and we find out there are 24 ways that we can give Mel some marbles and Nora the rest. And that's it. That's the answer. The answer is 24. Everyone follow? What do you think about that? You like it? And Nikhil, is this what you did? Is this the approach you found? No, Akshay, because if there were 3 people there, then you'd have to actually care how it was distributed between the remaining 2 people. And actually, I think that would go beyond what the GMAT could do. I don't think the GMAT could do this problem with 3 people. I think that would be, at that point, too hard. Oh, D, thank you so much. Yeah, Brian's awesome. I love his videos. He's a good friend of mine. He's actually my boss. You can give him some shit about this problem if you ever see him. You can like, ha ha, Brian, I did this better than you did, because he's the guy who I was talking about. But yeah, definitely check out Brian Galvin's videos, because he's really great too. Much better than me. Glad you like the approach. Is there a way to apply the distribution approach here? No, I would just pretty much do this. I don't think I'd have another approach to this. As in for each marble. Well, I mean that kind of is what I'm doing, right, Siddharth? But the thing is, the duplicate marbles, they're all the same color. So I'm saying, well, for the red marbles, let me distribute them between Mel and Nora. There's 4 ways to distribute the red marbles between Mel and Nora. None to Mel, 1 to Mel, 2 to Mel, 3 to Mel, right? Like that is actually, Siddharth, that is what I think I'm doing. Now, one last thing before I close up about this. How are we supposed to see this, right? Because every time, I know the question is, yeah, that's great if you saw it, but how am I supposed to? How am I supposed to learn to think that way? Well, I'm curious. First of all, a couple of your names look familiar. Was anyone in my Thinking Like a Number Theorist video a month or 2 ago? Did anyone actually do that video with me or watch it later? If you did, do you remember the unique factors trick? Or even if you didn't do that video, do you know the unique factors trick? You know the thing where we say, hey, I've got 360 and I prime factor it, and it prime factors down to 2 to the third times 3 to the second times 5 to the first, and then I add 1 to each exponent. I got 4, I got 3, and I got 2, and then I multiply, and I say, there's 24 factors of this number, right? That's something we looked at in that other video, and maybe you know that from elsewhere, whether that video or somewhere else. That's called the unique factors trick. But wait a minute, why are we adding 1? Because we had one more choice. Because when I had 3 2s, I could take no 2s, or 1 2s, or 2 2s, or 3 2s. When I had 2 3s, I could take no 3s, or 1 3s, or 2 3s. Wait a minute. Wait, hold on. These are primes. Those were marbles. But isn't this the same thing? Aren't what we were doing in this problem, aren't we doing exactly the same thing here as we did here? Isn't this problem kind of a number theory problem? Isn't this just the unique factors trick, just with marbles instead of prime numbers? The formula is the same. Number of items in the category plus 1 to cover the choose 0 possibility, and multiply the results. It doesn't matter whether they're prime factors. It doesn't matter whether they're colored marbles. Yeah, that's why we add the 1, Siddharth, because that's what we're doing. We're doing basically that distribution thing. And there's a deep connection here between those 2 areas. And so what I would say is that if you don't understand the rule, if you just know the rule, you can't make this sort of connection. But one of my big crusades, and I've said this in some of my other videos, is that you don't just want to know the rule, you want to have a really deep understanding. You want to get why that rule is the way it is. Because then when you understand, hey, I know why the unique factors trick adds 1 and multiplies. I know why it works because I'm counting the number of options. Then that understanding can be exactly what inspires you when I give you this problem about marbles. You're more likely to think of, count the number of ways to distribute the marbles, don't forget to add one because you could get none of them. You're more likely to think of that if you really understood what you were doing in the unique factors trick. So if you want to be better at seeing different perspectives, then the more perspectives that you can truly master and really deeply understand, rather than just maybe memorize, the more you can understand them, the better off you'll be, the better you will be able to see problems in different ways and use what you've learned to get the shortcut. If each of them had at least marble, you would just eliminate 2 options. So actually, Kana, that problem would be slightly harder, but not that much harder. The answer would be 22 instead of 24, because what I would do is I'd say, well, of those 24 options, one option was Mel got none of the marbles, and that's bad. And the other option was Mel got literally all of them, and that's bad. So if it was an at least one marble, not just at least one of each color, but at least one total marble, you would do sort of total minus bad equals good. You'd say there's 24 total outcomes, you'd subtract the 2 bad ones where Mel gets all of them or none of them, and that's it. Okay? So that was my presentation. I hope I've given you some new ways to think about problems. I hope I have taught you some things about mental flexibility, both why it's important and what you need to do to get better at it. I was really happy to hear that some of you were able to apply those ideas on the last problem or two and get better results. And that's all I've got time for. That's my presentation. Again, my name was Anthony Ritz. My company was Veritas. I hope to see you again sometime. Thanks, guys, and have a good night.